In this video, we are going to be learning log base 10 and natural log. These two types of logarithms are so important that they're placed on most good calculators. Log base 10 will be a button that just says log. Natural log will be a button that just says ln. So, whenever we don't have a base specified, anytime you see a log without a base specified, then you just have to assume that is log base 10. So for example, if you see log x, that means log base 10 of x. Natural log is referred to ln, so if we have natural log of x, then it is the same thing as log base e of x. So for example, if you see ln x, then that's actually log base e of x. So what is e? E is a very useful number when you get to calculus, and e is equal to 2.71828, and this number keeps going on forever. I'm not really going to discuss the meaning of this because it is beyond our topic. Alright, so let's do some examples about log base 10 and natural log. Okay, so this is our first example. Log 8x plus 4 is equal to 2. Then what is the value of x? As we learned before, if the base is not specified, then we're going to assume that that's base 10. So log 8x plus 4 is equal to 2. We can write this as log base 10 of 8x plus 4 is equal to 2. So now we are going to take 10 to the power of 2. So 10 to the power of 2 is just going to be equal to 8x plus 4. 8x plus 4. And 10 to the power of 2 is equal to 100. So 8x plus 4 on the left side. So now I can subtract 4 from both sides. Let's subtract 4 from both sides. And now I'll get 8x on the left. Positive 4 and negative 4 will be cancelled out. So 8x is going to be equal to 100 minus 4, 96. If we just divide both sides by 8, so divide both sides by 8 to get the x, so x is going to be 96 divided by 8. So if you just divide 96 by 8, you're going to get 12. So x is equal to 12 in this equation. X is equal to 12. Alright, let's do another example. So as you can see, we have log. The base is not specified, so log 7 plus log base 3 of 5x plus 2 is equal to 1. So here, if the base is not specified, we can just write 10 here, okay? And 10 to the power of 1 is going to be this expression, okay? 10 to the power of 1, so let me put the equal sign here. Let me write this expression first, so 7 plus log base 3 of 5x plus 2 is just going to be equal to 10 to the power of 1. 10 to the power of 1. So 10 to the power of 1 is 10. 10 to the power of 1 is 10. So 7 plus log base 3 of 5x plus 2. Now we can subtract 7 from both sides. Let's subtract 7 from both sides of the equation. 7 and negative 7 will be cancelled out. 7 minus 7 is 0. So on the left, I have log base 3 of 5x plus 2. And on the right, 10 minus 7 is equal to 3. Right now, 3 to the power of 3 is just going to be this expression. So let me write that on the left-hand side. So 5x plus 2 is going to be equal to 3 to the power of 3. 3 to the power of 3. 3 to the power of 3. So 3 to the power of 3 is 3 times 3 times 3, which is 27. So I'm going to write 27 here, and I have 5x plus 2. And then now I can subtract 2 from both sides, because I want to get x alone. So that means first I'm going to get rid of positive 2, and then I'm going to get rid of 5. So subtract 2 from both sides. So 2 minus 2 will be 0. 5x will be left on the left. And 27 minus 2 is going to be 25. And then now I can divide both sides by 5. I can divide both sides by 5. So 25 divided by 5 is going to give us the answer. So 5 times 5 is going to be 25. So x is equal to 5. So the solution to this equation right over here, this is going to be the value of x here will be 5. X is equal to 5. This is question number 3. So ln x plus 2 is equal to 3. So what is the value of x? So as I told you before, whenever you see ln, that means it is a natural log. It means it is log base e. So log base e of x plus 2 is equal to 3. So here e to the power of 3 is going to be equal to this expression. So x plus 2 is equal to e to the power of 3. So x is going to be e to the power of 3 minus 2. So you can use the e button of your calculator and take the power of 3, and then you can just subtract 2 from that. So alright, so let's use the Google calculator. So e to the power of 3 is just going to be e times e, right? So, or we can use this, e to the power of 3 minus 2. Yes, e to the power of 3 minus 2. That's going to be 18.08, and it actually keeps going on forever. So let's just round that to the nearest hundredth. So that let's make it 18.09. Okay, 18.09. So x is approximately 18.09. Alright, so I'm gonna write another question. Question 4. We have log base 3 and in brackets 6 plus ln x minus 4, and this is equal to 2. So 3 to the power of 2 is just going to be equal to this expression. So 6 plus ln x minus 4 is going to be equal to 3 to the power of 2. 3 to the power of 2. 3 to the power of 2 is 3 times 3, so which is 9. So 6 plus ln x minus 4 is equal to 9. Then we can subtract 6 from both sides. So ln x minus 4 is going to be 9 minus 6. 9 minus 6. 9 minus 6 is equal to 3. So that's ln x minus 4. So ln is actually log base e, right? I'm going to write log base e. So log base e of x minus 4 is equal to 3. So that means the base to the power of this number, which is e to the power of 3, is going to be equal to x minus 4. So now I can add 4 to both sides to get x. So x is going to be e to the power of 3 plus 4. So in this equation, x is going to be, so here the question was the value of x. So x is going to be e to the power of 3 plus 4. Question 5. ln e cubed plus log base 5 of x minus 3 is equal to 3. So what is the value of x? So we have here the natural logarithm. So that means the base is e here. So we can write this as log base e of e cubed plus log base 5 of x minus 3 is equal to 3. So here, e to the power of 3 is going to be equal to this expression. So that's going to be e cubed plus log base 5 of x minus 3. So if I subtract e cubed from both sides, let's subtract e cubed from both sides. Then, on the left, I'm going to be left with log base 5 of x minus 3. And on the right, I'm going to be left with 0. E cubed minus e cubed is going to be 0. So now, 5 to the power of 0 is going to be x minus 3. 5 to the power of 0 is x minus 3. So 5 to the power of 0 is equal to 1, because any number to the power of 0 is 1. X minus 3 is equal to 1. Then I can add 3 to both sides, and I can find that x is equal to 4. Question number 6. Log a is equal to x and log b is equal to y, and a times b is equal to 1000, and x plus y is the question. So first of all, as you can see here, the base is not specified, so we can say that this is actually base 10. Log base 10 of a is equal to x, so that means 10 to the power of x is equal to a. A is equal to 10 to the power of x. And log base 10 of b is equal to y. Log base 10 of b is equal to y. That means b is equal to 10 to the power of y. 10 to the power of y. So now, we know that a times b is equal to 1000. So I'm going to replace a by 10 to the power of x. And I'm going to replace b by 10 to the power of y. So instead of a, let's write 10 to the power of x times, and b, 10 to the power of y, is equal to 1000. Alright, now we have the same basis, so I can just add the powers. That means 10 to the power of x plus y is equal to 1000. Can I write 1000 as a power of 10? Yes, because 10 to the power of 3 is equal to 1000. So 10 to the power of x plus y is going to be equal to 10 to the power of 3. So we have the same basis in this equation. So the powers must be the same. X plus y is equal to 3. X plus y is equal to 3. So the question was x plus y. As you can see, the question was x plus y, so x plus y is equal to 3 is the answer. Question number 7. X is equal to log 1000 and y is equal to log base x of 81. So x times y is the question. Okay, so as you can see, the base is not specified here, so we can write log base 10 of 1000. Log base 10 of 1000 is equal to x. That means 1000 is equal to 10 to the power of x. 10 to the power of x is equal to 1000. So we know that 1000 is actually 10 to the power of 3. That means x is equal to 3 here. So x is equal to 3. Now I need to find the value of y. So it's given that log base x of 81, log base x of 81 is equal to y. That means x to the power of y is equal to 81. So x to the power of y is equal to 81. So we just found that x is equal to 3. 3 to the power of y is equal to 81. And we can just prime factorize 81. So we can just prime factorize 81. 81 is, we know that it is 9 times 9. And if you just prime factorize 9, you're going to get 3 times 3. And 9 is 3 times 3. So 81 is just equal to 3 times 3 times 3 times 3, which is 3 to the power of 4. So 3 to the power of y is equal to 81 is 3 to the power of 4. That means y is equal to 4. So the question is x times y. So the question is x times y, which is 3 times 4. 12 is the answer.